In this video, we will be talking about chemical changes. We need to basically discuss what are chemical changes, how we can look at the chemical changes, what are the characteristic feature of a chemical change. So there are two types of changes, physical and chemical. So when you talk about physical changes, there are change in the physical properties of anything. When you talk about chemical changes, you are talking about changes that are taking place in its chemical properties. So that is the definition also. A change in which two substances came in contact with new substances formed having different properties is called chemical change. So the thing here is, since you are playing with the chemical properties, so there are higher chances that there will be new substance that are going to form. It is not necessarily what you can say can be the condition that new substance will form, but most of the time it is the condition where like it is the thing that you can see that new substances are forming. So in that case, you can say that's a chemical change. Now, a chemical change cannot be reversed, because if once, let's say, if something is formed, then you can't go back to its original state. So that is another characteristic feature, that it is irreversible, whereas the physical changes are reversible. Okay, so thus a chemical change is permanent and is irreversible. Now, here you can see the different examples of chemical changes, like the cooking of food. So once you cook the food, you can't go back to its original state. The way you have like put the vegetables into the pan. Simply with the growth of a plant, once the seed is put under the soil and it basically turned into a plant, so you can't just go back to the seed. I mean, plant will give you the seed, but the plant itself cannot go back to the seed. Same thing, the curd that is made from milk. So once you get the curd, you just can't go back to the curd. From the process of photosynthesis also, once you are able to utilize the gases, or you are able to form the molecule of a glucose or whatever is involved in this process of photosynthesis, you just can't get that back. There might be another process through which you can get these back, but not from the actual process. Okay, so like these we can consider, like such examples we can consider it as a chemical changes. Okay, just look around you and figure it out by yourself. What are the changes that are taking place around you, and then classify them as physical and chemical changes. Okay, another example would be like very easy example is what happens to the food that you eat. Okay, the food that you eat undergoes the chemical reaction inside your body and changes into the new substance, and this change is permanent. Means what we are trying to say here is, once you eat the food, you just can't actually convert them into the state in which you are eating. Let's say you're eating chapati or a rice. When it digested into your body, you just can't get back the rice or the chapati as a whole thing or as a whole substance. Okay, so like that, these are something which you can consider as a basic criteria of a chemical change. Now with a simple activity also, I can show you the chemical change. So our aim is to observe the chemical change with the iron nails. Okay, we're taking small iron nails just to understand the chemical change. So these iron nails are there. So the material that we need, obviously, with shiny iron nails and a plate. So what we do is we take a few shiny iron nails in a plate, place this plate in any moist place out of your house, observe them after a few days and note your observation. So what you have to do is just take these iron nails, keep them somewhere where there is a moistness, means there is some water and the air has to be there. It should not be some dry place. So what you will see after a few days, that there will be a brown layer that is formed on the iron nails, because once we put that, those are shiny iron nails. Now they have this brown layer which is called rust. So now they get rusted, and we cannot get back to the shiny nails from the rusted one, because the rusting of iron is a chemical change. Once you get the rust in an iron, you just can't go back. Okay, so this is like a very important thing. So like this you can understand the chemical change. Okay, another very good activity should be this. Okay, so here what you can do is, let's say our aim is to show the burning of a magnesium ribbon, which is also a chemical change. Okay, so for that we need a magnesium ribbon, a sandpaper, a pair of tongs, a burner, a test tube, a dropper, and a blue and a red litmus paper. Okay, these are our requirements. So what we have to do here is, we basically take a magnesium ribbon and clean it with a sandpaper, so that it should be there should not be any kind of impurities. Okay, so that is why we are using a sandpaper. Then once we use a sandpaper and clean the magnesium ribbon, you have to observe its color. Okay, so what you will see is it's like little bit shiny. It's all clean now. Now you have to hold it with a pair of tongs and heat it on a burner. And then you have to note your observation when you are heating it. Okay. Now let the magnesium ribbon burns completely and collect the substance formed and observe its color also. Now you have to keep on observing the colors after every state or after everything that you are doing during this experiment. Now can you change the ash back or formed back into the magnesium ribbon? Is it possible? And do you think a new substance has been formed by burning the magnesium ribbon? Now take a test tube and put the powdery ash in it. Add little water to the test tube, okay, and shake well. Put a drop of this solution on blue and red litmus paper and note the color change if any. So you can see there are multiple things that we need to do. First of all, if we clean it with a sandpaper, then what will happen? So magnesium ribbon basically have this grayish kind of a color. So if you clean it with sandpaper, it will become more what you can say shiny appearance. Now again, the second thing would be when you hold it with a pair of tongs and heat it on a burner, what you will see is that magnesium ribbon burns with a dazzling white flame. So that is the color of the flame when you are burning it. Okay, and once it is burning completely, it forms the ash, the powdery ash. Now the powdery ash you formed is not the same as the magnesium ribbon, which is like the color that the magnesium ribbon has. Okay, the color of the magnesium ribbon is completely different than what you get as a ash. Okay, so the ash would be more blackish comparatively to the magnesium ribbon, which is more grayish and shiny. So our conclusion is that the powdery ash is a magnesium oxide which have a very different color, and a change has occurred on burning a magnesium ribbon, where you can see that magnesium burns with the presence of oxygen to form magnesium oxide. It should be like this, Mg and O2. Okay, so this will give you 2MgO. So this is your magnesium oxide. So magnesium and oxygen react together to give you a magnesium oxide. So on mixing magnesium oxide with water, a new substance called magnesium hydroxide is also formed. So this can be represented as follows, where magnesium hydroxide plus water will give you magnesium hydroxide, which is MgO plus H2O will give you MgOH. This will be whole twice. So that is magnesium hydroxide. So you can see that after every step there is something new that keeps on forming. So when such new things are formed, you can say that that is a chemical change. Now what you have to do is you have to test whether this magnesium hydroxide is like what color it is giving when you're testing with litmus paper. So litmus paper basically tells you whether something is acidic or basic. So it is basic because it turns red litmus blue. Because if blue litmus becomes red, it will tell you it is acidic. But here it is turning from red to blue, so it is basic. It is a base. So burning of magnesium ribbon is a chemical change. Like all of these things can actually tells you that it is a chemical change. In that whole experiment, the one thing that you have to take care is that you should not look at the burning magnesium ribbon for a long, because it may harm your eyes, because it is having this dazzling white flame, so you might not able to see properly after for a few couple of minutes. So that is why you have to make sure that you should see here and there as well when you do this experiment. But at the end, what you are able to get from this experiment is that how the chemical change occurs and what are the things that you might see in the chemical change. Now look around you, find the chemical changes that are happening around you, and observe your uh, what I can say, just see what you are observing. Find the answers in your observations, that okay, what is exactly happening. I hope this topic will help you. Thank you.